So today's lesson is 4-4, which is evaluate algebraic expressions. Okay? So the first thing we're going to do, well, first I want you to know, let me click this so it stops blinking. All right. So the first thing I want you to know is this definition of evaluate. Evaluate means to substitute and simplify. Make sure you write that down. Substitute and simplify. Okay? So the first thing I want to do is we want to sort the statements that are down here below into the appropriate bins. The first bin says algebraic expressions, and the second bin says numerical expressions. Okay, so on your paper, I want you to write a table. One that's titled algebraic expression on the left, numerical expressions on the right. So down below, we have evaluate using order of operations. We have contains numbers. We have contains variables. And we have requires replacing variables with given values. So, and it also says up here, some statements may be used for both. So, what am I going to put? Where am I going to put evaluate using order of operations? Does that go in algebraic expressions or numerical expressions? What do you do when you are simplifying? You're going to put that in both, because in order to simplify algebraic and numerical expressions, you have to use your order of operations. Is everybody with me? All right. How about contains numbers? And we're done with this one, so we don't have to use that anymore. So, contains numbers. Where does that go? Good, very good. So both of those algebraic expressions have numbers and numerical expressions have numbers. So we're done with that one, contains numbers. What about contains variables? That one is going to be algebraic. Do I have anything for any variables in numerical expressions? Nope. Nope, so we're done with that one. And requires replacing variables with given values. Let's take a look again. Requires replacing variables with given values. That means putting a number in for the variable. That's going to be algebraic. Because do I have variables in numerical expressions? No, you don't. So that one would not be in the numerical expressions. It would just be in algebraic. So to evaluate an expression, you don't have to write that in blue again. You already wrote it down at the beginning, right? To evaluate an algebraic expression, you substitute and simplify. So here, I want you to write down the definitions for substituting and simplifying. So substitute means that we're going to put a number in for a variable. Make sure you write that down. And then, once we do that, then we simplify using your order of operations. So, for example, we want to evaluate 4x plus 2. 4x equals 2. Now, before we begin, can you tell me what 4x means? X. Very good. That means 4 times x. So, the first thing we want to do is we want to substitute. So, that means wherever there is an x, we're going to put in a 2. Is everybody with me? So, we have 4 times 2, because we know 4x means 4 times x. 4 times 2 plus 2. And now we simplify using our order of operations. So what do I do first in this expression? We do 4 times 2. So 4 times 2 is 8, plus 2 is 10. And there's our simplified expression. And if you're showing your work correctly, again, you have an inverted triangle. Example 1, we're going to evaluate one-step algebraic expressions. Now, here, example A says evaluate x over 6. What does this fraction bar mean? Division. Very good. So, you guys, you're going to write evaluate. You're going to write your original problem. Always write your original problem. So, you're going to write x over 6. You're going to write x divided by 6. Now, we substitute. So, what goes in for x? 42. So, 42 gets substituted in. And now, we simplify. So, 42 divided by 6, 7. And it's as simple as that. So, let's do it again. So, we have x divided by 5. Write your original problem. X divided by 5. What goes in for x? 60. And then we simplify. 60 divided by 5 is equal to 12. So, example 2 is to evaluate two-step algebraic expressions. So that first one was one step. Here's two step. That means we have two operations. Okay? So again, we're going to evaluate. And the first thing we're going to do is we're going to substitute. Very good. So wherever there is an A, we're going to put in -3. And wherever there is a B, we're going to put in -6. Is everybody clear? All right, so let's substitute. So we've got -5 times A, that's times -3, plus B, which is -6. So now we're going to simplify using our order of operations. So what comes first? -5 times -3. Very good. And a negative times a negative is a positive. So -5 times -3 is positive 15. So now we're going to add a -6. What is the rule when we're adding integers with different signs? No, we do not keep change. We subtract the digits and keep the sign of the bigger number. Very good. So 15 minus 6 is 9, and my sign is going to be positive. Very good. And again, there you go, you guys. There is your inverted triangle. All right, so go ahead and take 2 minutes and do example B with your table partners. The first thing you need to do on this problem is you need to substitute, right? Did everybody get their substitution correct? All right, so now we want to simplify. Okay, good. So here, first thing we're going to do is 3 times -4. Positive times a negative is a negative. So we have a -12 minus 2. Now, with subtraction, what is the rule? Now we're going to keep change. So we're going to add the opposite. So negative plus a negative is a negative. You add the digits and keep the same sign, right? So -12 plus -2 is very good. -14. So if you got the other number that you guys were saying, it's because you need to make sure you follow your integer rules. All right, example 3 is evaluate multi-step algebraic expressions. Okay? Make sure you write this down first. Do this right now. All right, so example 3a, we have x over 4. Remember that over 4, the fraction bar means what? Divide. Very good. So we have x divided by 4 plus 2 times the quantity, y squared, minus 3z. We want to evaluate that when x is equal to negative 12, y is equal to 7, and z is equal to negative 8. So the first step is what? No, what's the first step? Substitute. Substitute. So all we have to do, wherever there's an x, we're going to put in negative 12. Wherever there's a y, we're going to put in 7. And wherever there's a z, we're going to put in negative 8. You please pay attention to detail. So we've got x over 4. So that's going to be negative 12 over 4 plus 2 times quantity, y squared. So y is 7. So we have 7 squared. Minus 3 times z. Z is negative 8. So that's 3 times negative 8. And then we're going to close parentheses. All right, so now we simplify using our order of operations. So what goes first?
3 times negative 8.
We want to do the stuff that's in the grouping symbol, right? So in my grouping symbol, what comes first? The exponent comes first. So we're going to do 7 squared. You see that? So we've got negative 12 divided by 4 plus 2 times 7 squared is 49 minus 3 times negative 8. Close parentheses. So now, inside my grouping symbol, what do I do first? 3 times negative 8. Very good. So here, we're going to do, let's do this. We're going to do 3 times negative 8. All right. So we've got negative 12 divided by 4 plus 2 times the quantity 49 minus, and then negative 3 times negative 8 is negative 24. What do you notice about a negative and a negative? What's happening there? We have to, that becomes a positive because we're going to keep, change, change. That's the next step, right? Keep, change, change. So now we have 49 plus 24. All right, so we've got a negative 12 divided by 4 plus 2 times 73. Now, what comes next here? What? Negative 12 divided by 4. So now, we've got, what's negative 12 divided by 4? Negative 3. Plus, can I do this one over here now? It's left to right, right? So now, what is 2 times 73? 146. And now I've got negative 3 plus 146. What's the rule for adding integers with different signs? Beautiful. Subtract and take the sign of the bigger number. So we get 143, and my sign is going to be positive. All right, take 2 minutes and do example B with your table partners. Okay? So the first thing you're going to do is you're going to substitute. Okay? All right, so the first thing we want to do here is the grouping symbols. Now, we have a grouping symbol here. Now watch how I do this problem. You don't have to do it one at a time. And we have a grouping symbol there. Oh, let me do it in a different color. We have that grouping symbol, and we have this grouping symbol. Okay? If the grouping symbols are separate, you can do them at the same time. Now, inside this grouping symbol, we're going to do that exponent, okay? And then after that exponent, then we're going to multiply. On this one, we're going to do our multiplication from left to right. So here, we're going to do this multiplication and then do the next multiplication from left to right. Is everybody with me on that? So, we've got, and I'll just take it one step at a time, we've got 3 times 4 plus 4 divided by, so now we're going to do 4 times 6, that's 24, minus 2 times 4. Now, inside the rest of the grouping symbols, we can do the 3 times 4, and we can do the 2 times 4. So here, we've got 12 plus 4 divided by 24 minus 8. Is everybody with me so far? So now, what's 12 plus 4? 16. And now, over here, we've got 24 minus 8, which is 16. And 16 divided by 16 is 1. And there's your final answer. Example 4 says use algebraic expressions. It says the expression 1/2 A times the quantity B plus C can be used to find the area of a trapezoid, where A is equal to the height and C and B are equal to the two bases. What is the area of the trapezoid when A is equal to 4, B is equal to 6, and C is equal to 3? So we're going to write the original problem right here. This is going to be 1/2 times A times the quantity B plus C. So now we're going to substitute in. So for A, what am I going to put in for A? What goes in for A? 4. Very good. You guys can call out when I ask. So here we have 1/2 times 4 times, what goes in for B? 6. Plus C, what goes in for C? 3. Very good. So now, so there's our substitution. What do I do next? Good. So now we're going to simplify. And what we're going to do is the grouping symbols first, right? So we have 6 plus 3 is equal to 9. All right. So we have 1/2 times 4 times 9. Now, this is all multiplication now. Can I do this in any order I want? Yes, you can. You can do this in any order you want because it's all multiplication, and multiplication has the associative property, okay? I'm going to choose to do the one that I could take half of. Does everybody see that? Half of 4. That's easy, right? That's going to be 2. So we've got 2 times 9, which of course is 18. And because this is area, this is centimeters squared. Is everybody clear?